works, huh? Let's see how this works. I hope this works. Yeah. I go live here. See if we're going live. Think we're starting to go live. Hey, how's it going, everyone? My name is Johnny, but I go by the YouTube name Chontech. Hopefully you can hear me and everything that I'm saying right now. Hopefully I have everything set up. I don't really do live sessions all too often, so I thought I might actually try a live session. So I normally teach students all about how to do printed circuit board assembly, for those of you who don't know me out there and who may just happen to catch this in the group. I don't know kind of who's going with this here. I don't know what to expect, who might show up here. But one of the things I thought I'd like to do kind of to end the day, I've been teaching all day today. I've got a couple of things uploading and coming up online, is I thought I'd do a little bit of some instruction on some techniques that I've developed in terms of soldering and solder wicking. Some of this may be for folks who are new to this, who have never attempted to actually solder anything for the first time, and that's usually the type of students that I get at the college that I normally teach at. So I usually get students who have never soldered anything before. So what I thought I would do is try to make a short video and kind of walk you through some basic steps in steps in safety and soldering in terms of what I typically do. So specifically soldering with the soldering iron, I myself use a Hakko 951 soldering station. It's been a absolutely wonderful soldering station so far. And it's something that I frequently find myself teaching my students on how to use as well. So what I'm using in my hand right now is a Hakko soldering tip, and this is by far my most favorite soldering tip, and you'll see why here in just a little bit. It is a T15JS02. Slightly bent soldering tip is what it is. This soldering tip slides into the Hakko handle here as such, and snaps into place like that. Then the handle that I've got here, which is wired into the solder station, which is located behind my microscope here. My microscope, which has a camera attached to it, and I'll be soldering some of the components here live on the camera for those who just happen to be catching on for the first time. I have no idea to even tell if there's anyone even watching. I've got no clue. So if you are watching, you might be kind of interested in this. Leave a little chat. See what you like to think about this here. So the Hakko 951 soldering station, I'll be turning it on with a power switch right now behind my microscope, which is currently saying that there is a disconnection. You hear that beep? That means I have not pushed the tip in all the way. Now, big safety thing. Whenever you're using a soldering iron and a tip for a soldering iron, make sure that you have a silicone hot pad or something on your gloves to be able to help to kind of push this thing in all the way. You don't know if this is hot, and the last thing that you truly want to do when using a soldering iron is accidentally touch the hot end of the soldering iron. Okay, that's usually an ouch if it's hot at all. Metal tends to sometimes have heat retained in it after you're done using it, so you may not want to do that. All right, so let's push in the soldering iron and make sure we hear that snappy click. I love that click because that tells me it's connected, and it tells me that my power station won't beep at me like that, All right, so let's turn on our soldering station here. For those of you who are kind of watching, and I see I've got a couple of people watching here. Hi, how are you? If you are watching this, this will be posted up to my YouTube channel as well if you're interested in kind of catching on and finding anything else about this. So the reason that I like this soldering iron in particular so much is because if you look at it underneath the microscope, hear that beep that tells me I'm up at 610 degrees Fahrenheit. The reason I like this soldering iron as much as I do is because if you are looking at the tip right now underneath my soldering iron, you'll see that it is somewhat bent. It is somewhat dark right now. I'm going to try to increase the light so that you're able to see it a little bit better. You see that? This tip has a bent tip to where part of that tip is actually somewhat flat. So the tip, this is unlike, someone might be looking at this that's like, I've been to Home Depot, Lowe's, and other hardware stores, and I've seen soldering irons, and they've got a point. They've got a point. They've got a tip which looks like this guy does right here, this T12-BL, which if you were to compare these two tips to one another, the one in my right hand, oops, sorry about that, excuse me. Let me go by LED one on my board here. This is one of my test circuit boards that I provide over to my students that I train normally. So this is one of the first ones that's there. The tip that's in my right hand, that's the typical one that you will find with most soldering irons. For most like general purpose stuff, I guess it's okay. But the bent one is going to be a lot better. And here is why. Soldering is a conduction-based process. It's a process by which heat travels down through the cone of the tip and actually heats up the part by transferring heat and conducting it through pathways. The more of the area of the soldering iron you can apply down to the pad, the faster it can heat up to the temperature that it takes to actually cause the fusion to occur. So it's actually, hey Mohad, how's it going? Yeah. So the better that you can actually connect this soldering iron tip up to whatever it is that you are trying to solder, the faster it's going to be able to send heat towards that part. Now, with a conical tip, kind of like this guy is right here, with a conical tip, this is not going to be as efficient at transferring heat down to the part. So the reason that this conical tip, I mean, like if you picture it, I mean, let's pull out, let me put my soldering iron in my cradle here, and I'm going to pull out an electronic component that is going to, oops, excuse me about that, put that back on the screen there, R1. Let's attach what we would call a 1206 resistor to spot R1. And I've got some sample resistors here on paper, tape, and reel, standard method by which resistors, capacitors, and other sorts of components get attached to it. And I'm going to pull a couple of components out of here. So I'm going to show this kind of on screen just to show you what it looks like. See the little sprockets on there. That's for the surface mount feeders that normally have to feed these into parts for doing automatic assembly, spaced at, I think, 4 millimeters apart from one another. So let's peel back the plastic film that covers the part and pour one of the parts over. This is a 151 ohm resistor is what this is. 151 being on there, if you can, oh, see that. Sorry, my tweezers still have just a little bit of some fluxing agent, and I'll kind of explain a little bit about what that is here in just a second. I'm going to use a little bit of some rubbing alcohol to help clean up my tweezer ends to it here. So let's clean that up. The fluxing agent I use, which I'll explain a little bit about what that is here in just a second, is tacky. So it does have a little bit of a stick to it at the very end of it, but works quite well, as I'll soon show you kind of on here. So let's move the rubbing alcohol back, and I've pulled a couple of other components out of the tape and reel. All right, so R1, which is slightly off screen right now, R1, which is located right over here, R1 is a 1206 resistor, to which the 1206 meaning that it's an English unit. And for those of you who are in the metric system, yay, you've won. Fortunately, us here in America, we're still using a little bit of the inches in everything that we do. So what 1206 stands for, it's a geometric measurement of the package. That means that the length of this package here is 0.12 inches by the width over here of 0.06 inches. So 1206, 1206. That is the length by the width measurement. The actual size of the package is what that is. So let's move this chip resistor a little bit off to the side right there. We're actually going to attach this chip resistor to position R1 using my Hakko soldering station. First thing I'm going to do is I'm going to take a syringe barrel of a little bit of some fluxing agent. Now, flux in general helps to give me a better solderable contact to, oh gosh, is that my email that's going right now? I think that is. Let me turn that off real fast. I'm doing a live show, sorry about that. So what the fluxing agent tends to actually do is to help to provide a little bit of a better solder contact to it. So it does a couple of things. Number one, when activated, meaning that it has heat applied to it, the activation actually dissolves oxidation and skin oils to a certain extent, organic based contamination. Skin oils is the typical one, and there's lots and lots of other examples to it. But two, because it's dissolving oxide, the rust that forms on metals that are in the circuit board area, that dissolving of the oxide actually forms a better soldered contact. towards what it is that we're trying to solder to. And so because it's such a better solder contact, it has a better way of being able to get connected up. Hi, everyone. Hi. Thanks for joining along with it here. So I'm going to use some 0.015 inch diameter solder wire that actually has a little bit of some fluxing agent on the inside of it. But fluxing agent, the resin that's on the inside of most solder wires, that's usually only good for through hole. I mean, it typically is only good for through hole. Surface mount, the fluxing agent is in many ways the secret sauce to what it is. So I'm going to hold my soldering iron down. And you see this? I'm not just able to apply the flat cone. Like, I'm not just able to apply the little tip. I could apply the flat tip down to the pad, which will melt my solder to it here. But I can not only just apply that, I can also apply the whole entire side of this if I wanted to really heat something up, or if I'm in an absolute hurry for something that's smaller than the size of a 1206 resistor, and I want to ignore all the IPCJ standard based stuff and all the rest of that, and all those certified based things, I can actually heat up both pads at one time on either side of a chip resistor without necessarily having to wedge my arm inside of strange ways with it on there. So I may not necessarily want to really be able to do that. So now what I'm going to do is I am going to touch my iron down to this pad, and I'm going to attach the 1206 chip resistor over to its spot, making sure that I watch for the solder to be able to run its way down and over. This is the other really nice thing about being able to use a bent tip in comparison to a conical tip, which is just coming down to a straight point, is that if I want to just heat up the end of this right here, I can stick the tip on there, and eventually that will heat up the solder joints. That will absolutely heat up the solder joints. Sorry, let me get that closer to the center to it here. This will absolutely heat up the whole solder joint. And you can kind of see how it takes its time being able to do it. You can see the solid to liquid transition happen, which, if one were counting, I'm going to count in, 1, 2, 3, there with 3 seconds roughly, or I really got to get my job done faster and a little bit better to it. So I'm going to touch this to it right there, and boom, the whole thing's heated up in less than a second. And I've got the ability to do that at a fairly rapid rate, is where that is. And with efficiency as well. I can't tell you how many times I've poked a circuit board by putting the point of the soldering iron down, that can destroy tracks, that can destroy traces, that can make the circuit board look ugly. And no one wants an ugly circuit board. Let's be honest here, folks. Let's be honest. No one likes an ugly circuit board. When you open that circuit board up and you see burn marks, scratch marks on there, you know where the problem is at that point. So let me take my soldering iron, and I'm going to flip the chip resistor around. I am right-handed, so I generally tend to do a lot of stuff with my right hand, and I switch back and forth between the different components that I am trying to attach and remove to these spots here, right? So I'm going to now heat up the other side of the chip resistor right here and apply, and my soldering wire got all bent up when I was putting underneath the camera here, making sure that I'm still on the screen. And you can see that there I've applied a little bit too much there, but that's okay. Applied a little bit to it. I can take the flat side of my soldering iron and just kind of lay it flat down against the part that I want to solder, and solder it. It's much easier to work with in comparison to a conical tip. As a matter of fact, let's kind of show what this is here just a little bit. So what I'm going to do is I'm going to turn off my soldering iron. I'm going to take my ceramic soldering iron holder. This is a good thing to have because when I'm about to take this tip out, in general, I don't know if this is hot or not. I'm going to assume that it is hot so that I can take my silicone hot pad. I'm going to disconnect the soldering iron from here. My soldering iron is off, sitting in the back of it right there. Take my soldering iron out, right, and put it into the area that's right over there. Very good. Now I'm going to take my conical soldering iron tip, which this one's actually, this again is a T12-BL by Hakko soldering tip, is what this is. This one is actually completely brand new. I have never used this one before. And I'm using this, if you're wondering, I'm using this with my Hakko 951 solder station. So now I'm going to make sure that my tip is fully inserted. Hear that click? Hear that click? That's a good click. That's what that is. That's an excellent, excellent click. Click. Yes, hi. Those of you joining, hi, how are you? Hi. Leave a chat there if you're interested. I'm just doing a little bit of some basic solder exercises. These are for some folks who may not have done soldering, something that's a little bit new for folks who have never done some soldering before. So what I'm going to do now is kind of show you so here's my tip that's all the way up there, and I'm up at 610 degrees Fahrenheit, and I'm going to touch the tip of this to, you see how long this takes? Do you see how long, look how long that transition is. That is taken way, way too long. And I'm just touching the tip to this on here. All I'm doing is touching the tip to it. Granted, maybe some of you might be saying to yourself, why don't you tin your brand new tip before you actually use it, Professor? So that's what actually I'm going to do. I'm going to use some tip cleaner that I have right here, and dip my iron into the tip cleaner. And the tip cleaner allows me to do cleaning of any oxides that may be on the tip and provide a fresh layer of tinned solder on the end of that tip. This stuff costs like maybe $8 to $12, something like that. This is 100% worth purchasing something like this, as it extends the life of the soldering iron for a lot longer than it takes to act than you will actually typically have. So now let's try it with a tin tip and see if there's any difference to it. No, look at that. Look how slow that is. Do you all see that? Do you see that? Hi, Rod from Brazil. Hi, welcome to the show here. Thank you very much for joining on. Glad to see you here. This soldering iron, this conical tip, takes so long to be able to heat something up to the point in comparison to that bent tip soldering iron. The bent tip, and again, in comparison, what we're doing right now is we are comparing, in my left hand, the soldering iron I'm currently using, to the bent tip of the T15-JS02 soldering iron tip. And the one in my right hand right here, and the one in my right hand, this is honestly my favorite tip. I use this for a large variety of jobs that I need to be able to get a lot of heat to quickly and efficiently, is what it is. So this is the one I'm using. I've never really understood much about why you need this conical tip, other than the fact that I know like right now, I am holding this on its side. I am holding it in a way that I was not trained to use. Eating utensils, pencils, pens, anything like that. I wasn't trained to do anything when I'm holding it kind of like this here, you know? So now I'm holding it awkwardly, and if I touch it to the side of it, well then, yeah, now it all heats up really well. But now I have to produce, I'm lucky I'm working on something on this side of the, with nothing located to my physical hand space right. Because normally when I hold a soldering iron, I hold it like a pen. It's shaped like a pen. Hakko makes this nice little grip that reminds me of the pens that I had when I was in little school, like in grade school, And so with this tip that's on here, I normally have to hold it like this. So if I want to hold it continuously like this, I still have to wait all this time for the solder that's in here to completely reflow over to its liquid state. I don't have the time for that. I really don't. Let's demonstrate a little bit more by looking at R2. Let's attach another 150 ohm resistor. Again, 151 is what's being attached to it on here. Let me put that guy down to the bottom side of it there. Let me make sure that R2 is on screen, so to speak. There we go. So I'll just kind of place that there. I'm going to take my fluxing agent that I've got in my syringe barrel and apply a generous amount. Fluxing agent is cheap. It's especially cheap. We pay, I think, for a 10 cc syringe barrel of this stuff. It costs like $12 American is what it costs. That is very inexpensive in the grand scheme of things in terms of how well it also works as well. It's efficient because it just makes soldering surface mount components easier in terms of being able to get it done to where it's correct. And maybe what I'll do is I'll demonstrate that. I'll solder one of these other components on to one of these spots here, just with the use without any fluxing agent at all, or at least attempt to remove all the fluxing agent. That's the third thing. Rubbing alcohol pretty much just completely removes this fluxing agent. Very easy thing to be able to remove. So first things first, what I'm going to do is I'm going to tin the top pad of my board over here. So I'm going to apply a little bit of some tin. That actually worked pretty well for what that is, but let's see how well this works. I'm going to switch the soldering iron from my left hand to my right hand. and then attach this guy down to it over here, and put that guy, and that actually worked pretty well. That actually worked pretty well. Now, yeah, you see, I don't know if you saw that little part that was on the end of it right there, that little kind of point that was coming out. I've heard that point called a lot of things. I've heard one company call it the dog tail, which I actually think if you're looking at it on its side, it does kind of make the thing look like it's got a dog tail to it, which is really funny. I've heard it called stalactites, which might actually be the real technical term. I don't know. I teach this, but I'm not formally trained in how to do it, I guess might be the easiest way to phrase what that is. I've just been doing this for so long and enjoy what I'm doing so much that I like just doing what it is that I do. So, but yeah, that dog tail, as I'll call it. If you have other words of what you call that, leave a comment down in there. What do you call this little spike that's on here? There, I've got one right there. You see that? You see what that is? That little spike that's on there. Let me kind of show this at a little bit of an angle. You see that little spike? Do you see that little spike on there? That spike is a huge no. That is a huge no in electronics. I don't want a metal spike that's sticking up twice as high as the circuit board components. Someone's going to yell at me for that. Probably the customer if it winds up making it that way. If not, hopefully the AOI systems or the other sorts of electronic inspection stuff will hopefully be able to detect that, right? So now what I'm going to do is I am going to attempt to fix it, right? You can probably see it a little bit easier right about now in terms of where that is. So hopefully you can kind of get a good look of what this is. So if I try to fix this using the conical tip soldering iron, I'm going to come on into here. Oh gosh, I gotta wait for the whole thing to heat up. Oh, there we go, finally. All right, now let go of it. Let go. Oh no. Oh no. I've got a worse dog tail. You see that? You see that? That's terrible. I don't want that. I don't want a tall spike sticking out of this. Yeah, here, I'll come on down and try and fix this again here, you know? Oh gosh, let go of my part. Oh no. I got it again. This is a problem, right? Well, problem number one is I haven't really tacked down the other side just as of yet. Why don't we do that real fast? Let's use my conical tip soldering iron, and I'm going to kind of use it at its side. This is sort of cramping for my wrist in a lot of ways. I'm going to hopefully heat up the part in the pad by making as much contact as possible, and there I go. Now I've got a little bit better of a contact. Let's see if I can remove that stalactite from here. I'm going to try to come down towards the bottom of it. That actually kind of removed it there, but no, that almost did. That almost did. Oh, almost did. No. 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 That's still there. It's still there. That dogtail is a problem. That is a problem because if one were to look at this, hi everyone joining on here. Hi, how you doing? So if you were to look at this thing, that really does kind of look like a dog. I really do like that term. I haven't used that in the past. I've always used the term stalactite, which is like those things that hang from caves, like the triangular conical looking things that have rock formations that hang from caves. Stalactites, stalagmites, that kind of, I think, are the general words that get used. I don't want to have that on my circuit board because it's taller. It's twice as tall as the part. That could interfere with a whole variety of different things. Fluxing agent is a better way to help remove it. So what I'm going to do is I'm going to apply a dab of fluxing agent onto the top of it. Okay? I'm going to apply a little bit of fluxing agent onto the top of it. I'm going to take my soldering iron and I'm going to wait for it to heat up to its 610 degrees Fahrenheit, which is indicated by the beep. And I'm going to come at the bottom of this, just barely touch the part, wait for the whole part to heat up, and voila, no stalactite. Now that did take a little bit of time. You notice I touched it and had to pull away making sure I was touching it, but then touched it again. That's because of this conical tip. I don't like this conical tip for that exact reason, actually. Let me cause a stalactite on this side here. Let me see if I can't pull. That's a good one. Now the doggy has turned to the other side. Now the dog tail is on the right hand side. We don't want that, right? Let me go back to, I'm going to turn off my solder station, and I'm going to pull my soldering iron out of its cradle. Every time I put it in its cradle, by the way, this cradle, it costs a little bit more. It costs about $100 extra more, $100 US extra more. But when I put it inside this cradle, there is a switch that ceases the heat going to it stops the heat going to the tip of the soldering iron, and really does help prolong the life. I'm someone that teaches this for a living, so I do have to worry about people that accidentally leave soldering irons on from time to time, especially if they're new at it, they've never done it before, which, I mean, we've all been there before. But the nice thing is about this cradle here is that when I put it back in there, it turns off the heat. It's got a nice little beveled area that I can put this soldering iron in, and overall makes an easy way to be able to use the tools that need to be used in order to do the things that we need to do. All right. So let's see here. I thought something was hot for a second. I spooked myself. How many of you have done that at some point before, or something like that? All right, snap this guy in using my silicone pad. Make sure I've got. That felt like it was pretty firmly in there. Let's see. Let's see if it beeps. Does it beep? Any beep? No? I actually inserted it in there all the way. Hooray! That's good. I actually did the right thing. Okay. So now what we're going to do is use the side end of this end of the tool. Got a little bit of some fumes coming off of a potentially a. Oh, this is an older tool that's with it. That should be even better. Let me make sure that it's tinned. So I'm going to use my tip cleaner real fast. Clean off the tip. Highly recommend if you're using tip cleaner, the typical tip cleaners, they smell. They smell bad. One of the things I'm using behind me right now is a fume extractor system. A fan works. Like, this is a $20 fume extractor. It has a little bit of a filter that I can change out from time to time. But even just any regular old fan, it's worth it. It's worth it in a long shot. I myself like the smell of flexing agent, but some people really don't, and it's not always good to inhale fumes. And this isn't a health and safety thing in terms of that respect. So, but at the same time, fume extractor, fan system, ventilation system of some sort, highly recommend. So now what I'm going to do is fix the dogtail that's on the other side. So there's a dogtail that's currently on the right-hand side of what it is I'm trying to work on. And I'm going to take my soldering iron. Well, first take my flexing agent and wrap it sort of around where that mark is. And now I'm going to come in with my bent soldering iron tip, making sure I'm on screen. Hi, how are you? Hey, everyone who's joined. Hey, how's it going? How's it going here? So now I'm going to come at it, kind of tip this down. Watch how it melts. Do you see how fast that was? Do you see how fast that was? That was fast. That was fast. That was efficient. That was easy to do, because all I have to do is lay the flat side of my soldering iron down, and I'm not awkwardly turning my hand or anything like that. This tool, this bent tip, is a marvelous, marvelous thing. And I wouldn't have thought so. I actually didn't think so at all, because I was like, well, why do all the stores sell straight tips? I've never, or like, you know, wedge tips, like flat tips. I've never seen a bent tip really used in the industry. And I was relatively new in learning this one at the time. And I've learned this is really kind of a, you know, this and the fluxing agent, these are two very good secrets at learning how to do standard surface mount components without having a variety of issues with how it's actually been connected to it on here. Now, another thing that I learned at first, and I definitely made this mistake. Let me try and attach R3 for a second. I'm going to try and attach R3. And again, these are 1206 resistors. So these resistors are not, oh, I did say I was going to try and attach a 1206 resistor without the use of fluxing agents. Let's also try that too. That's going to be fun to be able to do. I'm not going to use fluxing agent for anything that I'm going to work on at first here, right? Granted, my core of my solder wire is a fluxing agent based, it does have a core, a flux core on the inside of it, but it's 0.015 inches in diameter, so it doesn't have very much of it. I probably could use something a little bit better for a 1206 based component. But here's something that you don't want to do if you have to do any surface mount based stuff by hand and you don't have any other tools except for a soldering iron available and some solder wire. What you don't want to do is what I'm about to do right now, putting the tinning of the first pad and the tinning of the other pad right here. You have doomed yourself at this point to making it more difficult to be able to do the thing that you want to do, like so. I'm going to take, you know what, on a variety, I had right here a 150 ohm resistor, and I'm just, that's lost somewhere. So let's pull out just a slightly different number. What we got here? Let's see. What do I got another strip. I got another tape and reel on here. I've got another tape and reel with a 223. Or sorry, a 223 is what's written on the resistor. That is a 2. 2 followed by 3 zeros, meaning that it's 22 kiloohms is what it is. 22 kiloohms is what this is. Right? Now, I'm not using fluxing agent at all, although I might still have a residual that's left over on my tweezers from just generally using it. So let's zoom on in. Let's zoom on in. 22 kiloohms is what that is. All right, let's solder this guy on. I'm going to try and solder the left side on first. It's usually just what I try and do here. And I'm going to try and solder the left-hand side of my 2 tin sides. And okay, I've got the left-hand side down. I think that's down. I think they didn't really quite flow over the chip component all too well. Not as well as the last one. All right, now I got to be able to get the... Oh, I can't get the right-hand side, and I've already got a dogtail happening. I already have a dogtail. That looks terrible, right? Don't you think so? Leave a comment somewhere in the comments there if you think that looks awful. Like, this is, someone take a picture of, someone take a screenshot of this. This is an absolute, like, world's worst looking soldered component ever to it there. You see that? So. All right, so how do I fix something like this here? Well, truth is, this is a hard one to fix. Most especially, this is a hard one to fix without fluxing agent to it. So, usually speaking, when you are soldering components by hand, the best practice that I've found to do is to tin one pad, tack it down to that one pad, and then start to do all of the other pads. This works for everything except for some of the quad flat packs, which after the one pad is aligned, align up all of the other pads and then just do one on all 4 sides of the quad flat pack, and then check the alignment again afterwards. It's just some of the cases, some of the pitch between one pin and the next is so critical at this point, is what it is. Yeah, it is another dogtail, isn't it? That's a real good one. That might be the best one yet, all right? And we're going to try and fix this dogtail as well. We absolutely will try and fix this dogtail. So let's try and do so right here. It's an excellent point here, Rod. So let's see. First thing I need to do is I need to remove this chip component. I'm going to take it off of its spot here. I need to remove the solder from the second pad. And the best way to be able to do that is to wick it, is to use something that's called solder wick, is what that is. I'm going to turn off my soldering iron. I'm going to use my silicone tip to remove my solder iron, is what it is. And I'm going to use some solder wick, is what this is. Solder wick is actually nothing more than braided copper wire, is all that it is. Copper and tin are like sponge and water. When you put copper, especially heated copper, near tin, the tin will get absorbed into the copper, is what it is. So I need to be able to apply heat onto this copper wire. And I'm going to kind of demonstrate this using a third tool that I've recently come to love, absolutely love this third tool, and that is a Wicking soldering iron tip. Where did I put my Wicking soldering iron tip? Are you in there somewhere? Are you in there? I've got to pull this out. Oh, there you are. There you are. It's the tallest one out of the group. Should have known. Actually, this one is, I shouldn't have known. I wouldn't have known that. This is a relatively new tip for me. This is, the model number is T15-BCM2. Again, by Hakko. And I'm not sponsored by Hakko or anything like that. I've used Weller tools. I've used Metcal tools before. The one that I've got in my house, I used kind of the same thing that I'm using over in my labs. I just using Hakko for it on there. It's the college degree that I teach. I have to get my students internships in order to get them their degrees. The internship is actually a requirement for the degree. And I just asked the majority of the companies in my area, well, what kind of soldering irons do you have? And 75% of them said Hakko, so that's just what I bought so that I can help train my students in the tools that they need to use to be able to get the jobs they need to get. So let's put this guy down into it right here. Take my soldering tip, make sure it's snapped into place. Hear the click. Good click to it on here. Turn this up. Now the reason that this is a better tip than either one of my other tools for wicking is because when you look at this tip, there is a gigantic flat zone on this tip. In fact, this tip here, let me hold it in a way where I'm not going to be getting the So not only is there a giant flat zone on the tip, but you see the inside is actually kind of beveled in. It's concave in on the bottom of the tip, allowing for solder to actually be able to kind of collect there and form like a mass of solder there. It just helps with wicking tremendously. It makes it very, very fast at being able to do it. Let me kind of demonstrate this on both of these pads. I'll retin them, and I'm not using any flux or anything like that right now. So we're going to do this fluxing agent free is what we're going to be doing to it. So now I'm going to take my solder wick. I'm going to come over to the spot where I have attached the chip component. I'll do that one first. I'm going to point the flat end of it down, and we can see that in a matter of seconds, the pad is clean of solder. It's all the way fresh down to the base of it on there. And then on top of that, if one were to look at the wick, that has now turned silver. I don't know if you can, that's hard to tell. It's hard to tell on that side. Maybe it's easy to tell on this side. Yeah, you can kind of see it there. The solder has been absorbed into the part where I have pressed down, lightly pressed down with my soldering iron onto that spot to remove the well, I guess I fixed the dog tail, didn't I? I fixed it by removing it. So we'll make it again. We'll make it again to it on here. We will. So now I'm going to take that soldering iron tip out, and I'm going to substitute it back in with a conical one, the conical one that I was using before. Let's see here. That is the T12BL. That's me. So now I'm going to press this thing down into my handle and press this down into here. Those of you who may be interested in doing this, check out my YouTube channel. I'll be posting some more videos over to this Facebook group, but check out my YouTube channel. I do a couple of additional videos of soldering and circuit board assembly, as well as some little videos for the kids that kind of help them with science, just looking at stuff underneath the microscope. Let's all face it, things look really cool sometimes underneath the microscope, and so that's kind of what I did. So now let's turn the soldering iron back on. I didn't hear the click originally, so this might beep at me. Oh, that sure did. You hear that? It says I'm not happy. I don't have a connection of the soldering iron into my heating element. There's the click, a good click. Turn that guy back on again. And now let's do the same approach with the, actually here, first thing we need to do is we need to remove the end of the wick that has the solder on it. And do I not have a pair of snips near me? I have misplaced my snips. Completely live on camera, clearly misplaced my snips. Well, that is what it is. That's oh, here they are. They are underneath my multimeter. And one that I'm doing right now is the wick itself is a consumable. So you see that like that silvery part of the wick? This is going to be chopped off at the very end of it. And I'm going to chop this one off first just to show that, you know, it's easy thing to be able to do. There's the extra wick. I'm going to take my pair of tweezers and throw this away in my dedicated disposal bin right behind me there. Now I've got some fresh wick to be able to use to remove the other one, but I am going to be using the conical tip to remove the other one right here, which may not quite go as smoothly because, as you well imagine, this is a conduction-based process. And doing this with a pinpoint that's on here, so here I'm gonna touch the tip of this with more or less the flat part of the pin, and top of that, I'm just having a problem. Okay, let me just turn the wick so that maybe I can get more of the flat part of it down. See this? I still haven't melted it, and there it's melted at easily 3 or 5 times more later. I haven't even removed all of it either. So let me spend a little bit more time cleaning this up to it there. That's pretty close enough. And some of the wick from the other side has kind of moved its way on over, so that's a little bit more clean in terms of where that is. Let me get rid of my excess part of the wick. Wick is reusable to a certain extent, but it's ultimately a consumable that is going to be consumed up, so you want to keep a couple spare rolls of it kind of lying around just in case. Okay, let's go back to soldering this component on, and I'll keep the conical tip that I've got going on here. That shouldn't be too hard to really be able to do. So first thing I'm going to do is I'm going to tin my one pad, which takes a little bit of some time to do. There we go. I'm going to find my component, move the soldering iron to my right hand, or excuse me, move the soldering iron to my left hand, attach the component into the mix. I've watched the solder kind of reflow over. Move it into in general into the silk screen. Come on, you can move in there a little bit better than that. There we go. Uh-oh. Look what formed. That's okay. It's just a little dogtail. Here, I'll fix the little dogtail. There we go. Oh, I moved the part. Well, that's a problem. I haven't tacked down the other side of it yet. I should probably tack down the other side of it. Did that get rid of the dogtail? That didn't get rid of the dogtail. It doesn't get rid of the dogtail. Did you all see that? There's still a dogtail there. Rod, we're back at the same problem that we had before. Oh no. So we got to fix that. First thing we got to do is tack down the other side. All right. Let's see. Let's put that guy down there. And I bent my solder wire just a little bit as it was coming on in. So let me fix that. Put this guy down to the other side. Make sure that the solder has flown over there. And voila, a little bit of a dogtail. Let me see if I can fix that guy. Let me see if I can fix the... Well, that kind of fixed it. Yeah, that's looking better than where it was. Oh, nope, that's a problem. That's a problem. There, I'll fix... Oh, no, that's a problem. Well, now I do have a problem. What is the word for an animal with two tails in your place? I don't think we have animals that have. If I were to see a dog with two tails, I would assume that there is either a science experiment going on or I'm just dreaming at that point. So I'm not sure what to think about that. I've really never thought about that before. Either way, this is not really what we want at all. This comes from not using fluxing agent. This is a common problem. Now, there is a way to solve this. There is sort of a way to solve it. I'm going to kind of do this with the board kind of on its end here. By touching the more or less flat part at the base of this here, and then moving it kind of away from it as such, like kind of like from here and away, that is somewhat able to fix it to a certain extent. But you see what I've got to do? I've got to angle everything all at those odd angles, especially with this conical tip. I'm not a huge fan of really being able to do that. So instead, what we do is we take a little bit of this fluxing agent, this tacky flux. All right, just put a little bit of it on there. You don't need very much, although you can be generous with the amount that you actually apply to it on here. And I'm going to touch the base end part of it on here, making sure I heat the whole thing up. And voila, dogtail removed. That's what that is. Fluxing agent really, truly helps. And is an easy thing to be able to remove as well. So when I am ready to remove this particular fluxing agent, I grab just a basic Q-tip. Oh gosh, that is a used Q-tip is what that is. That was used in a previous experiments. Do I not have any Q-tips in front of me? I don't have any Q-tips in front of me. Do I have any Q-tips behind me? Yes, I do. I have some additional ones behind me, slightly off screen here. Let me get back on the screen. Hi, didn't go anywhere. I'm still here. So now what we're going to do is take some isopropyl alcohol, some electronic grade isopropyl alcohol, and come on into each one of the parts. Let me kind of zoom out a little bit here. And this will more or less clean up a majority of the flux. Now, ultimately, the better way to really be able to do this is through the use of an ultrasonic cleaner. I think is the best way to truly be able to clean up everything is using isopropyl alcohol mixed with some distilled water in an ultrasonic cleaner. That's always the way that I've kind of found is the best way to be able to do this. Be that I don't have an ultrasonic cleaner at home, the next best thing to do is to be able to rub it with a little bit of some alcohol on all the sides of this here, and kind of give a little bit of a cloth to wipe the thing clean. And what do you think? Not too shabby, huh? Not too shabby at all. So, yeah. So a little bit of some tips and some soldering, some tips about soldering tips, if you will. The main tip of the site is that, honestly, my preference personally, and everyone's got their own personal preference, maybe leave a comment in the comments about what your personal preference is that the bent tips overall provide better contact over to being able to make contact over with the end of the chip. Ultimately, the conical ones, as popular as they are, they just don't seem quite as practical. They are cheap, I'll give you that. They are usually the cheaper ones. This bent one wasn't too, I don't remember it being too much in comparison to the conical one, but it definitely was worth it. And then for wicking, for doing a solder wick process, the larger flat-tipped ones. The more area that you can press that wick down onto the pad, the better it's going to work. And in particular, that flat-tipped T15 BCM2, which I think that there may be another number at the very end of it, but I can't read that on there. I mean, the fact that this has the kind of the bevel that's in that little area that's kind of been milled out, that's at the tip part of it there, that makes this work so well for wicking things that are on the 1206 sizes on here, and the rest of the pads that are here as well. Yeah, so those are the tips that I recommend, and using the equipment that I've got here. Going to kind of end this here in the next couple of minutes, unless I'm seeing there's still a couple people watching. Thank you so much for watching. Let me know in the chats or the comments if you've got any questions about this, and follow me on YouTube as well. This is something I'm kind of doing right now to help my college students who are also learning from home. We're all kind of learning from home for the time being, and trying to teach electronic manufacturing and soldering to students who are doing electronics is sometimes a difficult thing to be able to do, and kind of wanted to be able to create a YouTube channel for helping students be able to learn more about this, maybe get excited about it as well. There's still, to this day, nothing excites me more than, or nothing is interesting more to me than watching the way that solder melts when you have heat being applied to it on here. But yeah, check me out on YouTube as well. I'll be posting some more videos over to this as well. And I will see you all in the next video on there. All right. See you later. Bye-bye. Bye. See you later, everyone. Bye.